to an innovative development path is associated with large-scale investment in IT sector. The development of IT sector is a strategic resource that determines a place of national economy in a global economic system. In most countries, the IT direction is considered as a fundamental source of economic development and is the most important component of the basis of the development of Industry 4.0 technological process. The first international workshop on computer information technologies in Industry 4.0 is being held to unite scientists from different countries around a common cause and forming a field for exchange of opinion, knowledge, and cooperation. The level of education in society increases the number and the speed of scientific discoveries, as well as the speed of their dissemination in the manufacturing sector. Modern scientific and technological process has led to significant change in science and technology. On behalf of the rector of our university, Mykola Metnik, as me personally, I express my gratitude to all participants of workshop and guests who took the time to take part in this conference. I wish interesting discussions and new scientific ideas. Thank you.
Thank you, Professor Moroshchak. Andrei Stepanovich Sverstyuk, Professor, you're welcome.
Okay, thank you. Good morning, dear participants of the first international workshop on computer information technologies in Industry 4.0. I sincerely welcome you to a large scientific event, the purpose of which is to highlight and discuss the current state and features of the use of the latest advances in computer information technologies. Today, such industries as automation, electronics, and medical equipment cannot develop without information technologies. This approach ensures the creation of cyber-physical systems of virtual and augmented reality, management of physical processes, creation of intelligent systems, involvement of internet technologies. The listed industries are defined by the concept of Industry 4.0, which is the leading trend of the fourth industrial revolution that is happening now and uses the following technologies. The Internet of Things is used to organize the complex interaction of technical systems, devices, sensors, and their automated interaction with each other without human intervention, increasing the functionality of advanced high-tech industrials, technical and telemedical complex or systems. At the same time, the Internet is a medium for data exchange and provides appropriate interaction. The next example is digital ecosystems, which include various physical objects, software systems, and management tools that, thanks to information technologies, form a single whole. At the same time, a close relationship between physical and computing resources is ensured. At the same time, big data analytics is important, which includes the accumulation and processing of huge amounts of data as a result of digitalization of various signals of the physical world with the help of cloud computing and artificial intelligence technologies. The main goal of the past international workshop on CITI-2023 is to headline and discuss the latest scientific achievements in the field areas which combine modern technical achievements with information technologies. Once again, I congratulate all the participants of the first international workshop on computer information technologies in Industry 4.0. I sincerely wish everyone fruitful scientific work, good health, fulfillment of dreams, a quick victory and peace in Ukraine. Thank you very much.
Thank you, Professor Sverstyuk. And today is Andrei Sverstyuk's birthday. And on behalf of all the participants and co-organizers of this workshop, I would like to congratulate him and wish him good health, inspiration, and new achievements in the scientific fields.
Thank you very much.
Congratulations. So it's the first workshop, and we obtained approximately 60 papers, 60 submissions, and only 29 papers were accepted according to the recommendations of the reviewers. So there are 16 reports on the agenda today. And to start the work of the workshop, I want to give the floor to the head of our program committee, Vasil Martsenyuk, Professor Vasil Martsenyuk, and to present a first report. But he is not here, he is on meeting, he wrote to me. So maybe Oksana Bahri presents this work. So please, you're welcome.
Dear participants, my name is Oksana Bahri. I would like to present the result of our research on the topic mathematical and computer simulation of the response of potentiometric biosensor for the determination of alpha-chaconine. Nowadays, the concept of creating cyber-physical systems for various spheres of technology interaction with human activity is actively developing. Our work was supported by Erasmus project. The future is in applied artificial intelligence. In general, cyber-physical systems are considered as intelligent systems in which external devices, processors, physical objects, network equipment are integrated. The main purpose of cyber-physical systems creation is to monitor the behavior of physical objects as components of such systems in real time. These are systems in which cybernetic means measuring, computing, control interact with physical processes in arbitrary objects. Cyber-physical systems are attracting more attention than ever thanks to the rapid development of the Internet of Things and its combination with artificial intelligence, machine learning, and the cloud. Cyber physics of the system are identified with the manifestation of fourth industrial revolution that is taking place in the modern world. Thus, there is also the physical possibility of using Internet of Things technologies where signals from sensors and measuring instruments need to be used. Cyber-physical system technologies are already transforming the way people interact with engineered systems in the real or physical world, just as the Internet has transformed the way people interact with information. Yet, due to their complexity, the developers of cyber-physical systems face a major problem: the lack of simulation tools and models for their design and analysis. Cyber-physical systems are systems that integrate computing elements with the physical components and processes. The computing elements coordinate and communicate with sensors, which monitor cyber and physical indicators, and actuators, which modify the cyber and physical environment. Biosensors are analytical devices that use biochemical reactions to detect a wide range of chemical compounds, metabolites, medications, environmental pollutants, etc. This slide shows the principle of operation of cyber-physical biosensor systems, which can be used for medical and biological processes. The first, a particle of substance is measured, resulting in the formation of the product, which is converted by the converter into an electrical signal for data analysis. That is, the methods of molecular biology, electronics, and communications make it possible to monitor health, controlling chronic and preventing critical human conditions. Nowadays, there are different types of biosensors depending on the type of transducer, bioreceptor, and immobilization. Biosensors measure biological or chemical reactions by generating signals proportional to the concentration of an analyte in the reaction. The biosensor itself is typically made up of the following components. First, it's the analyte. This is the substance that is being detected. The bioreceptor is a molecule that recognizes this analyte. Examples of biosensors inside the body include enzymes, cells, and antibodies. The process of signal generation upon interaction with the bioreceptor with the analyte is called biorecognition. Next is a transducer, is the element converting the forms of energy through the process, which is called signalization. In this case, it's used to convert the biorecognition event into the measurable signal. The electronics element processes this transduced signal and prepares it for quantifying on the display. Finally, the display consists of a user interpretation system similar to that of the mobile phone screen. This part consists of hardware and software that will display the generated results in the user-friendly way. The display may show a numerical value and image or data in the table graphical form, depending on the requirements. In our work, we are considering alpha-chaconine. Alpha-chaconine is a steroidal glycoalkaloid. It's natural toxicant produced in green potatoes and gives the potato a bitter taste. The question is extremely relevant given that alpha-chaconine is a very interesting object from a biological point of view due to its toxicity and the determination of its concentration in potatoes as a very popular food product, due to which potatoes acquire a bitter taste. Measurement of the content of alpha-chaconine in potatoes is carried out when new varieties with reduced content are bred. The currently developed methods for determination of the alpha-chaconine are based on the colorimetry, chromatography methods, and radio or immunological analysis. But these methods are characterized with a very high cost, long duration, and complexity of simple preparation methods. In order to optimize and modify the existing methods, it's recommended to use more cheaper, more simple, and also a highly sensitive method, which is based on the using of biosensors. At the same time, with the purpose to save the time and to save materials, it's economically beneficial to create and research adequate mathematical models of biosensors for determination of alpha-chaconine with the possibility of varying the simulated response. The structure of ion-sensitive field effect transistor is shown in the slide. It consists of the source, drain, gate insulator, and reference electrode. The amount of the current flow will be not only determined by the change of the biomolecules interacting on the gate dielectric, but also sensitive to pH, different ions, products of enzyme reaction, etc. In our work, we are developing a mathematical model of the previously developed butyrylcholine esterase biosensor, which is based on the ion-selective field effect transistor for the inhibitory determination of alpha-chaconine. In recent years, scientific research has been conducted based on the results of which it can be concluded that mechanisms of resistance of potatoes to diseases and effects of insects depend on the level of alpha-chaconine. Among other factors that affect the level of alpha-chaconine, it can cause a significant increase in its initial concentration. It should be noted climatic changes, the effect of light, mechanical damage, and measurements which bring us constants were carried out using the portable device which was developed and manufactured at the Institute of Semiconductor Physics of National Academy of Science of Ukraine. In the slide, we're able to see the schematic representation of the operation of the biosensor, which is used for measuring the alpha-chaconine. Actually, this biosensor consists of 3 stages. Obtaining a baseline stage 0 responds to the working concentration as a substance stage number 1, and the response to alpha-chaconine as inhibitor stage 2. The functioning of the biosensor is based on enzymatic reaction that takes place in the bioselective membrane and can be presented in the following equation, which is shown in the slide. During the chemical reaction, protons are generated, which leads to a change in the pH inside the membrane. So it's advisable to use potentiometric biosensor, which is based on the pH-sensitive field effect transistor. Now we're able to see the schematic representation of the enzymatic reaction, and the mechanism of inhibition by alpha-chaconine belongs to the mixed type of inhibition. And this scheme we're able to see. Here we have the enzyme, substrate, and inhibitor. Also, all the components are listed down, and biochemical reaction rate constants K are difficult to obtain directly from experiment. In our work, these constants were selected in such a way that the model response coincided with the experimental responses. We built the system of 7 differential equations, and here we have the concentrations of enzyme, substrate, inhibitor, product, and also complexes: enzyme substrate, enzyme inhibitor, enzyme substrate inhibitor. And the change in the product concentration over time is directly proportional to the response of the biosensor. Also, we have constants which are in the system of 7 differential equations. All initial concentrations are obtained from the experimental data. And this experimental response was obtained at the concentration of an enzyme 5.8 times 10 to power minus 4 mole per liter. Experimental response of potentiometric biosensor for determination of alpha-chaconine we're able to see in the slide. And according to these results, the response of the biosensor for determination of alpha-chaconine was obtained at concentrations which are shown in the slide. And analyzing the numerical simulation results, we may summarize that the higher the concentration of the inhibitor, the smaller the response amplitude of the biosensor model under study. The simulated reactions of the biosensor at different concentrations of inhibitor fully corresponds to the principle of inhibition. And finally, we compared experimental data and model results. Model curve is in red and experimental is in black. And we may summarize that the input parameters of the system, their selection was carried out in such a way that the simulated response of the studied biosensor coincided with the experimental one on as much as possible. And about the absolute error of the simulation, the maximum verification error is manifested in the area of stabilization of the response of biosensor to the action of the inhibition and doesn't exceed 0.045 count units. And finally, the use of mathematical modeling to optimize the analytical characteristics of biosensor for determination of alpha-chaconine will allow to minimize laboratory experiments with toxic and expensive substances in order to select optimal concentrations of components. In future research, it's necessary to investigate the states of equilibrium and stability of developed mathematical models to develop software complex and design of cyber-physical systems for such biological processes. Thank you very much for your attention.
Thank you, dear colleagues. Maybe someone has questions about the report. Okay, so thank you. And dear colleagues, the head of our program committee, Professor Vasil Martsenyuk, is present here. Dear Professor, you're welcome.
Thank you. Dear participants of the conference, on behalf of program committee, I'd like to send our greetings and appreciations for participating at the conference. The topic of the conference is dealing with Industry 4.0, and currently we live at the times of so-called industrial revolution, industry 4.0, and we think that Industry 4.0 is the general topic which we are focusing on. Then another topic that the most of our reports were devoted to cyber-physical systems, and the first our talk was strictly related to cyber-physical systems, and the example from biochemistry is of interest, of course, and it is one of good practice for and very interesting real case for application of Industry 4.0 technologies. Nowadays, cyber-physical system implements integration of the computer layer and physical processes. That is, we can imagine cyber-physical systems as a union of physical processes supervised by information. Such processes can occur mostly in the form of embedded systems and networks for monitoring and controlling physical processes, operating in the feedback loop where physical processes are a source of data for calculating the object control signal. Also, cyber-physical systems identify with the manifestation of Industry 4.0 that takes place in modern times. That there is the physical possibility of using the, for example, IoT technology, where it's necessary to use signals from various of sensors and measuring devices. That is when analyzing the current literature, we have a growing number of publications that draws attention to the concepts of cyber-physical system, Internet of Things, and generally speaking, to Industry 4.0. They were offered the basic terms and the basic approaches for cyber-physical systems, such as dynamic logic, in order to describe and analyze cyber-physical systems. And the cornerstone of such works are hybrid programming, which capture relevant dynamic aspects of cyber-physical system in a simple programming language with a simple schematic. Hybrid programming allows us to refer directly to real-valued problems and specify the dynamics of cyber-physical systems. When summarizing the topics for the conference, we can here mention the some general topics of the works related primarily to cyber-physical systems, to Internet of Things, to computer networks, to cybersecurity, also the works related to e-learning and application of different branches of Industry 4.0 were submitted. I'd like to express general gratitude and appreciations for all the authors who submitted their works to the conference. And I wish a success and fruitful cooperations between the participants of the conference. Thank you for your attention.
Thank you, dear professor. And once again, I would like to thank you for your work in our program committee.
Thank you. And one point more. And here I'd like also to pay attention of the participants of the conference to the partner, namely the University of Bielsko-Biała, which I also present in here. The University of Bielsko-Biała pay a lot of attention to the development of the technologies like Industry 4.0, also to the questions related to cyber-physical systems and real cases related to, first of all, medical and biological systems and application of Industry 4.0 to such topics. Another thing that I'd like to mention here is the projects co-founded by European Union that the team and the consortium of University of Bielsko-Biała and other EU university are conducting. Here, first of all, I'd like to mention the project related to big data, and currently we are fulfilling the project relating to applied artificial intelligence. The main objective of the project is to join together higher educational institutions and business, IT business preferably, in order to bridge the current digital gaps regarding the applied artificial intelligence, to build an ecosystem of key partners from higher educational institutions and IT companies regarding applied artificial intelligence, and of course to support the development and implementing the training programs related to applied artificial intelligence. We are seeking the partners, first of all, associated partners that can be involved to the projects, and we are seeking for good practices, real cases in the area of applied artificial intelligence. Our team, the team of project FAI, also has submitted a series of works which will be presented throughout the conference, and I encourage you to take an active part at the discussion of the reports dealing with the above-mentioned program. Thank you for your attention.
Thank you. Maybe anyone has some questions, dear colleagues. So thank you again, and let's move to the next report. Digital twin implementation in transition of a smart manufacturing to Industry 5.0 point practices. The authors are Yunis Korenki, Roman Zolotay, Serhiy Fedak, Alexander Kramer, and Ruslan Kozak.
Thank you, Mr. Chairman. I will first extend my greetings to all participants of this first international workshop. Hopefully you can see the right screen now, and after introduction from previous speakers, I can skip most of detailed explanation to save time for discussion. So as you can see, I'm going to discuss digital twin implementation in smart manufacturing systems and prospects for development of new and much anticipated Industry 5.0. In distinction from highly automated and cybernetical Industry 4.0, which represent the current state of the art in this field, collaboration experience with improved human-machine interaction is characteristic to the Industry 5.0 concept. So we consider viable solutions for digital twins as human-machine interface and control units enabled by recent developments in field of augmented reality and virtual reality. As you probably know, as you surely know, smart manufacturing systems are defined as collaborative manufacturing systems able to respond in real time to conditions and demand changes. Digital twins, which are digital representations of physical elements, usually use IoT and sensor data to monitor operations, control physical elements, and support decision-making processes, as you already know, characteristic for cyber-physical systems. And that modeling of such systems are instrumental for such smart manufacturing design and can be used across multiple stages of the product of the manufacturing system lifecycle. To analyze and optimize energy consumption, in particular by smart manufacturing line, for which material flows, data flows are used as input parameters, we show in this figure 1 the process allowing us to design and deployment of analytical software platform. This slide presents a classification of data collected and processed in smart manufacturing important for such digital twin development. More details are given in our paper, and such a typology is quite generic, may be extended or reduced for particular use cases. But such classification is in principle needed to build data management system and manage energy data scenarios based on process parameters collected by cyber physical system. Identification of the most energy consuming processes can be made on the basis of such diagram, which may lead to integration of distributed procedure management and further data-powered optimization. Specifically selected smart sensors, meters, other monitoring devices which will be linked to manufacturing machinery are all sources of the essential data. Based on the data, reference metrics can
Dear colleagues, I'm sorry, but we had technical problems. Can you hear me?
Yes.
Yes.
I'm sorry against. Yuris Korenki, you completed your report? Dear Yuri Skorenki, are you here? Can you hear me? I'm sorry, there is a problem with internet in our university, in our campus. 2 minutes, please.
Can you hear me, Mr.
I
Chairman?
hope all will be okay. Good day, can you hear me?
As you want us every case is possible, so we can experience lots of different disconnections. Unfortunately, I will not be able to share my presentation again. So if you can launch the video, I will be the most grateful for that. Or otherwise, I can see that you still see my screen share. Mr. Chairman, can you still see my screen?
I'm sorry, but I can't hear you. Practically, it's very bad. You're working now from phone, yes?
Yes, that is the backup channel because something went wrong with the wired connection. So I suppose it will take me longer than the duration of the talk. And if you still see my screen, I will just summarize saying that we managed to solve the optimization problem and we constructed Lagrange polynomial, and details may be found in our submission, which I hope will be published in the book. Then those variables which represent the input and output parameters are the basis for. Actually, we use outputs in the iteration procedure to say refine the control parameter control signal. Therefore, we solve the general optimization problem, and then basing on that set of results, we construct augmented reality digital twin procedure. So the sequence of steps which we propose in our work for design and implementation of augmented reality tools for smart manufacturing are proposed, and then we analyze information security aspects. Because the information collected by such digital twin is the important and valuable business asset. Therefore, it's important to properly design and develop corresponding measures for assuring information security. We follow the STRIDE methodology and identify types of security threats. And for each element of such industrial data platform architecture, we build corresponding countermeasures which are to be implemented, which by design should be present there. And actually, our conclusions from this part of our project tells us that digital twins with augmented reality interfaces may become powerful enabler for realization of the transition to Industry 5.0, ensuring better quality of products, improved energy efficiency, efficient predictive maintenance, and so on. And implementation of digital twin may be supported by augmented reality assets. And this not only allows the remote control of the process in real time, but also enables predictive analytics and process optimization. And secure by design approach for digital twin is to become a best practice in this field. So thank you for your attention. I will welcome the most question and discussion, please.
So please, dear colleagues, maybe anyone who has some question. Thank you very much. And let's continue. The next report is input data requirements for person identification information technology. The authors are Katerina Merkulova and Елизавета Żabska. Please, you're welcome.
Thank you. Good afternoon, dear colleagues. For your attention presents the research of Taras Shevchenko National University of Kiev on the subject of input data requirements for person identification information technology. Improvement of face recognition and biometric technologies have led to increasing of accuracy, availability, and consequently to widespread usage of automated face recognition. It means that face recognition can be used on even larger scale and in more complex environments, for example, by special operation forces on drones for intelligence gathering, rescue missions, perimeter protection, and indoor search operation. However, the way in which face recognition and identification technologies are used for military purposes a subject of public criticism, because any errors of the software or those who are using it can have an irreversible consequences. Therefore, the study of recognition and identification algorithms is relevant in order to increase the efficiency and reduce the probability of false identification. In our previous work, the person identification information technology based on local texture descriptors was proposed, in which the algorithm is underlying that consists of the following methods: RF features for detecting and localizing the face region in images, Gabor wavelet transform for image processing, histograms of oriented gradients, and local binary patterns in one-dimensional space for extracting image feature vectors. Mathematical models of these methods are depicted on the screen. According to the results of our previous studies, the effectiveness of the algorithm used for person recognition and identification on face images can significantly vary on different datasets. Such problem can become a significant obstacle to the correct identification of a person and cause errors in the identification process. If the parameters of the images stored in the databases and the images that are given to the input of the algorithm are very essential. The purpose of this research is to determine the requirements for the formation of test and etalon image sample, the use of which would allow to obtain the highest accuracy rate results in person identification after applying the approved combination of methods. To conduct the experiment, 7 databases were selected that contain images captured in constrained as well as unconstrained conditions close to the natural environment in which human faces can be observed. Since face image databases usually have variability in image properties such as format, resolution, and the size of the area containing the person's face, it was decided to conduct experiments using different these properties to form requirements in regard to the technical characteristics of face images to which the developed algorithm will be applied. Thus, the experiments were conducted in 3 stages. The first set of experiments was performed on face images that were converted from the original format to the image formats BMP and PNG, which are compressed image formats, and JPG, which is uncompressed image format. The second set of experiments was conducted with the resolution conversion of the original image. The image resolution was converted to fixed height value only, and the width was automatically determined in such a way as to keep the aspect ratio constant. In the third stage of the study, experiments were carried out on face images transformed in such a way that the images contained only the face features of the person without any other detail. Since the results of the study are quite extensive, only some of the tables are shown on the slide as an example. On the screen, there is presented the comparative diagram of the results of experiments conducted on original images in this format conversion. Analyzing the results that obtained on the database of faces and infrared database, it can be concluded that the format of the images that are given to the input of the algorithm in some cases affect the efficiency of the algorithm. On all the other databases, the results are constant, regardless of changing in the image format. It is worth noting that all these databases contain images in JPG format, so this format is the most suitable for images to which the studied algorithm will be applied in the future. On the screen, there is presented the comparative diagram of the results of experiments conducted to investigate the resolution of input images, at which the algorithm is more effective. The highest identification accuracy rate among all sets of experiments, that is 95%, was obtained on images from the SC-face database, the resolution of which was converted to 108 on 144 pixels. On the screen, there is presented the comparative diagram of the results of experiments on images that contain only the face region without any other detail. Analyzing the obtained results, it can be concluded that the identification accuracy rate is significantly reduced when this type of transformation is applied to images. This may indicate that the face detection and region resizing methods available in the studied algorithm successfully process the input images, regardless of whether the input data contains any details other than the human facial feature. It is important to note that the image contained in all image databases on which it was possible to achieve higher accuracy results after applying the studied algorithm were captured in constrained or semi-constrained conditions. Database of faces contains image on a uniform background without frontal positions of faces. Parrot contains frontal images aligned and captured under the same physical settings, and SC-face contains images captured under the same lighting conditions using cameras that had an unchanged position relative to the subject. One of the mechanisms for increasing the accuracy of recognition and identification of requirements for images. Considering all the studies carried out in this work, it is possible to clearly formulate the described detail presented on the screen input images requirements regarding format, resolution, subject head position, lighting, condition, distance between the subject and the camera, time interval between the captures of the images, and so on. The results of conducted experiments allow to make the following conclusions. The lower limit of the accuracy of identification on images from all data sets was obtained during experiments with transformation of images in such a way that they did not contain other details except for the face region. It means that the face detection and localized region resizing methods contained in the algorithm are sufficient for further processing and successful classification of the image feature vector. Also, the impact of the format and resolution of the images given to the algorithm input on the subsequent efficiency of the identification process was found, which indicated the need to set requirements for such image parameters. The highest accuracy of identification of the algorithm was obtained after its appliance to the databases that contain face images captured under constrained conditions and uniformed without the database. So as a result of the research, it was determined that the proposed information technology allows to obtain the identification accuracy rate up to 95% during its appliance to images that were captured under constrained conditions and uniformed within the database. As a result of the analysis of experimental results, the requirements for the images to which the application of the algorithm is the most effective were determined. That is all. Thank you for your attention.
Thank you for your report. Dear colleagues, please ask your questions, if any. Okay, no questions. So thank you.
I'm sorry, I've got a question. Can I ask something?
Please, you're welcome, please.
Yes, Katerina Kozak from Electrical Engineering Department. I would like to ask you a question, please. Can you explain actually what is the main goal of your research and practicals here in the first part of the question, how it can help in your direction scientific? And the second one, what are you actually planning to investigate basically on your research? So you have now some backgrounds, and what are you planning to do in future? That is the second part of my question. Thank you.
Okay, thank you for your question. Regarding the first part, the main purpose was to increase the efficiency of proposed information technology by examining the prerequisites of the images that are given to the input of the algorithm that it underlies in the information technology. So as you can see on this slide, we conducted the experiments regarding format, resolution, and face region of images that contains only faces. So we changed these parameters of images to define if the algorithm efficiency depends on these parameters. And after in conclusion of these experiments, we determined the requirements for input images on which the algorithm will be the most efficient. And can you please repeat the second part of the question?
Yes, the second part. Thank you for the answer on the first part. The second part is actually about your future investigation and research in this sphere, basically on exactly these results which you've got here. So, are you planning to continue your research work in future, basically in this direction? And what actually do you want to have at the end? Your best result?
Thank you again for your question. For future studies, we are planning to investigate the pre-processing methods of the algorithm and what effect does they have for the performance of the algorithm. And the main purpose is to develop the information technology that will be the most effective in complex conditions such as presence of occlusion on the images, different lighting settings, and so on.
Thank you. I wish you good luck in your investigation.
Thank you very much.
Thank you. And the next report is methodology for evaluation the performance of website and its optimization using data mining technologies. The authors are Olena Syrokivska, Halina Kosburg, Irina Strutinska, Lilia Melnik, and Roman Sherstyuk. So please, your report.
Good afternoon. Can you hear me?
Yes, we can.
Yes, we can.
Okay, thank you. Dear colleagues, let me present the results of the scientific research on the topic methodology for evaluating the performance of websites and its improvement using data mining techniques. Today, one of the priority directions for the development of e-government in Ukraine is the creation of a digital ecosystem for territorial communities. It includes the following components: electronic government, digital infrastructure, digital services for citizens, services for business, and digital educational environment. And that is why the purpose of this investigation was to understand the state and functioning of community sites as a whole, to improve the system of criteria for evaluating the effectiveness of websites, to identify successful and problematic groups using the data mining techniques, as well as to develop a system of recommendations so that the sites become more effective. For this purpose, during September-December 2022, the authors of the article monitored the websites of authorities and local governments of 14 territorial communities of Chernobyl Oblast. In the evaluation process, each site received a score based on individual parameters. The system of indicators for each of the 15 sites contained 5 elements. Each of them contained a number of sub-criteria. The maximum possible value of the final assessment for each site was 108 points. An important task of this study in education, in addition to directly evaluating the sites, was to test the methodology of site research. Optimizing the methodology will increase the efficiency of further research and may be useful for scaling the research to individual regions or the country as a whole. To identify a possible correlation between the 5 main sign assessment criteria, pairwise values of Pearson correlation coefficients were calculated for all possible combinations of criteria. Note that the value of correlation coefficient does not depend on the order of the selected criteria. Therefore, the correlation matrix is symmetric for all pairs of criteria. All obtained values of pairwise correlation coefficient are entered in the correlation matrix. The values highlighted in the table greater than 0.5 indicate the presence of the positive linear correlation between this and that criteria and this and false criteria. This indicates that positive change in the value of one of the indicators lead to positive change in the average values of the other. A comparative analysis of the sub-indicators included in the specified pairs of criteria will make it possible to make a decision on merging the main criteria that showed a positive correlation or removing one criterion from the pair that showed a positive correlation from the system of criteria. This is the aim of understanding the state and functioning of community sites as a whole, identifying problem groups and developing a system of recommendations to improve the sites. The machine learning technique was applied, namely site clustering. So we use an algorithm calculates the square root Euclidean distance between elements in a cluster and the cluster mean and converge it on a final set of chi-clusters, then that sum reaches its minimum value. The cluster analysis made it possible to distinguish groups of community sites based on their similarity: 10 participants, 3 and 2 participants. The built clustering model allows us to find hidden structures in the information content of community or authority websites and to separate groups that have similar characteristics. The result of clustering can be used to identify complex relationships between information resources and improve the perception and use of information by citizens. The proposed methodology for evaluating community websites then used can have several key effects for the development of the e-government system. It could be improving interaction with the community, attracting new users, assessment of achievements and effectiveness and reputation improvement. The proposed methods of improving the methodology for evaluating the effectiveness of websites, correlation analysis of main evaluation criteria, and cluster analysis for community websites can be useful for reducing data processing costs, as clustering can help identify the most important characteristics of information sources that will be used for decision making in government processes. Thanks for your attention.
Thank you. Please, dear colleagues, ask your questions, if any.
Good day. Can I ask a question?
Please.
Katerina Kozak, a very interesting presentation. Thank you. I would like to ask, because it's a really important question and even important strategy in government in every town in Ukraine. Especially, of course, we are interested in Ternopil digital ecosystem. And the first question is about, well, we are talking only about ecosystem in government or in another sphere? This is the first question you've investigated, I mean. And the second question, what about sustainability? Is it one of the strategy of your research to become our town more sustainable? And the third question will be at the end. Thank you.
Thanks for the question. So first of all, we are talking about not about government, but about different types of community in our country. And and about business. So we have some platform for estimation of digital level of business structures in Ukraine. For example, small and medium business, because it's so important, and now we have no information what is the situation in our communities and in our business structures in our region. And second question was about sustainability. So we now have great cooperation with our communities, this other state government, and so we hope that our cooperation will have some correlation in the future.
Thank you. I would like to ask the third one question because it's really interesting direction as for now, and it will be about your point of view, and from your corner of view, what is the best model of digital ecosystem in our town in the sphere of e-government? How do you think? What will be the best model for us, like citizens of our town?
I think that it will be some digital model that will be useful for citizens, for different types of population in our town, in our city.
Okay, maybe you have some proposals how to make our life more easier when we want to submit some docs or something like that, if I understand from your side. Maybe some program.
So we have to create. We have to create sites on the level of community, and these sites could be more useful for different types of population.
Thank you very much. It was really interesting to listen to you.
Thank you.
Thank you. So the next report is software development for field-level industrial process control network system. The authors are Alexander Dobzhansky, Martin Bogdanovsky, Andriy Tkachuk, and Tatiana Vakaluk. Please.
Hello. Can you allow me to share my screen?
I'm sorry, the green button in the middle of a screen. Down. Share screen.
Share. Yes. I'm sorry. Take a moment. Can you see my screen?
Yes, but all.
Okay, this is our presentation.
Oh, no, yes, we can see.
Our thesis is about software development for field-level industrial process control network system. What is our goal and why did we deal with these issues? The knowledge of network distributed automatic systems still needs structuring and generalization. Why? This is because students obtaining a bachelor's or master's degree do not have the opportunity to acquire knowledge in a structured manner precisely on the issue of assembling network distributed automatic systems. It's about study materials that is still fragmented. It's fair, but it's true. The educational process requires a systematic approach to solving the issues of structuring educational materials in this sense. And that is why too, because we have industry requests. The practical implementation of control systems based on modern approaches makes it a problem for developers or system integrators to deal with choosing the software and hardware architecture of the future system. Instrumental structuring is present in production conditions, but this has not yet been reflected in the educational process as can be. The training methodology for the synthesis of network automation system has not yet been developed, although such systems in various forms and configurations are already being used in production. The ideology of the development of Industry 4.0 is far ahead in comparison with the level of education of the future personal staff of modern enterprises. What we have to offer? We training methodologies for the synthesis of the network automation system based on the ideology of the development of Industry 4.0, systematic approach, the structuring educational material, the transferring the latest production experience of elements of training, two elements of training, I'm sorry. Methodology for the synthesis of the field-level network automation system that we proposed. The study process stages must include next components and study sequence. Stage 1, defining hardware requirements, techniques of measuring, storage and execution of control programs, collecting and pre-processing, setting the configurations, setting the communication parameters, setting the software part stage of the software part creating, substage, visualization, and the defining of the special purpose power and process equipment which presents as an object. Stage 2, definition of software requirements. That may be support for generalized international standards, IEC 111, be case that is computer-aided software engineering. In other words, that is an array of software development tools which with elements of computer support such as templates, standard blocks, standard functions, automatic code verification, code and program interface links. Stage 3, definition of requirements for stages of automated control system synthesis. There are direct design of physical level without physical connecting, setting the configuration of the interfaces, and only next stage, substage programming. Stage 4, definition of the stage content of interface, configuration and programming tasks. What is it? It is direct debugging with physical connecting, setting of the configuration of the individual interfaces, programming visualization forms. And we made a probation recently, and our probation showed a good effect of knowledge transfer between years of study and decent assessments of residual knowledge for students that are studying automation. And our results was good. We have raised our percent in efficiency to about 82% of sufficient successful pass best test. Fair to point out that the students who got special knowledge in the early stage became understand the employer's requirements much earlier, and thus have a good motivation in studying. Our surveys of employers shows a confident increase in demand for field-level automation system specialists. And conclusions. We proposed methodological basics embedded in cluster of educational material, and is a skeleton that will allow building up structured parts, clarifying certain aspects of concrete practical issues regarding to development of distributed network systems of automatic control. Also, the presented methodology is open for revision and is not the last resort. Our approaches can be used to improve teaching methods and STEM tools for students who are mastering in automation and computer integrated technologies at the bachelor's and master's levels. In addition, a survey of employers shows a confident increase in demand for field-level automation system specialists. Therefore, the possibilities of learning and project development based on the pragmatic industrial use should be taken into account when formulating curricula for each study program in engineering. The presence of necessary elements in the education of a future engineer prevents degradation of industry, avoids decline in economy, supports sustainable development. And algorithm of our approach on some stage can be described in such manner as an example. It's one of the stage of our methodology approach. Thank you for your attention. And
thank you. Yes. Thank you. Maybe any questions, dear colleagues? Thank you. So I want to make a little change in our program, and next speaker, and I want to invite Sergey Vladov, Yuri Shmelyov, Ruslan Yakovlev, Tatiana Kozlovska, and Marina Pechenko. And report is helicopter turbostaff engines intelligent control algorithms synthesis, taking into account required quality provisions. So please.
Good day, dear participants. Do you see my presentation?
Yes, we can.
Yes, thank you very much. With your permission, I present a work, Helicopters, Turboshaft Engines, Intelligent Control Algorithm Synthesis, taking into account required quality provision. The helicopter's turboshaft engine automatic control system operation mode, after solving the problem of ensuring stability of the problem areas of ensuring the required indicators of the quality of transient process, overshoot, control time, and other. After these requirements are contradictory, which is primarily due to the peculiarities of the functioning of system. One of the promising directions for the development of helicopters turboshaft engine controls is the use of artificial intelligence component in their composition, production rules, fuzzy logic, artificial neural network, hybrid neural fuzzy architectures, genetic algorithm. Therefore, increasing the economic efficiency or maintaining a high level or reliability of the operation of helicopter's turboshaft engine at the stage of operation in condition of special operational situations based on the development of theoretical foundation, methods, and means of intelligent control of its modes in an urgent scientific and applied task. Modern approach to the implementation of the main strategies for turboshaft engine development, operation on condition, and ensuring system safety involve the intellectualization of turboshaft engine, all subsystems, and information integration with the engine control monitoring and diagnostic system, PADEC, in order to reliability assess the state, identify failures, and ensure normal operation engine due to PFADEC reconfiguration. Hybrid systems compared to the actual turboshaft engine operational status in terms of vibration velocity and vibration acceleration with possible typical operational status that are stored in the knowledge base of system, which will make it possible to classify the current turboshaft engine operational status and predict its further changes. This authors group developed a modified closed onboard helicopter's turboshaft engine automatic control system, which is supplemented with plug-in software modules that implement adaptive control methods. Each block of the developed modified closed onboard helicopter's turboshaft engine automatic control system is implemented using neural network technologies, which have shown high efficiency and stability in the research of transit process in the helicopter's turboshaft engine. However, the use of linear neural network did not solve the problem of overshooting the system. According to goal of the work, it is proposed to use the methods of synthesis of automatic control system using hybrid neural fuzzy network, HNFN. Hybrid neural fuzzy network combine the advantage of fuzzy inference system and neural networks. On the one hand, they allow development and presenting system models of the form of fuzzy production rules, which are visual to easy to interpret, and on the other hand, neural network methods are used to build fuzzy production rules, which is a more convenient and less time-consuming process for designers. The algorithm described and is used when construction of hybrid neural fuzzy network that implements decision-making on the choice of the system parameters in order to satisfy the given overshoot indicators. Figure shows the structure of the fuzzy inference system under consideration. The location of the coordinating part in the block diagram of the multiply connected helicopter turboshaft engine automatic control system shown in figure. In hybrid neural fuzzy network, logical conclusions are made using the fuzzy logic apparatus, and the corresponding membership functions are tuned using the neural network training algorithm. Backpropagation error. That is, the description of the research object is performed by fuzzy logic methods, and the tuning this model by artificial neural network method to obtain a more accurate correspondence to the considered model of the helicopter's turboshaft engine. The fuzzy inference system aggregates with a neural network. As a result, an hybrid neural fuzzy network of the ANFIS type is obtained, the adjustable parameters of which are the membership function parameters. Block diagram shows in figure. Units function analogous of neurons in the conventional neural network of the hybrid neurofuzzy network block diagram shown in figure are reflected in table. In the experimental work, the input signal obtained according to previous equation is used and analyzed for the CITI-2023 turboshaft engine, which is part of power plant of the Mi-8 MTV helicopter, according to the data obtained on board the helicopter during the flight. This slide shows the results of input signal pre-processing. After the randomization procedure, the actual training and test samples were selected in a ratio of 2:1, that is 67% and 33%. The distance between the cluster practically coincide in each of the considered sample, therefore the training and test samples are representative. As a result of the experiments of the development of the hybrid neurofuzzy network structure, the diagram was obtained shown in figure, where layer 1, 3 input variables, the parameters of which unequally determine the helicopter's turboshaft engine thermogas dynamic parameters values. Layer 2, 3 terms for each automatic control system input. Layer 3, 3 rules of fuzzy knowledge base. Layer 4, 3 classes of the output variable. Layer 5, the results is diffusivity. As a result of training the developed hybrid neurofuzzy network according to the algorithm described above, an object model was obtained with membership function parameters and weights of fuzzy rules, which are given in tables. As a result of modeling the dynamics of change in helicopter's turboshaft thermogas dynamic parameters according to the training samples, depending on the model time, they obtained the results presented in figure. This figure shows the calculation results of fuel consumption parameters in absolute units for precise modified closed on-board helicopter's turboshaft engine automatic control system, fuzzy and neurofuzzy control, reconfigured modified closed on-board helicopter's turboshaft engine automatic control system developed in this work, respectively for given values of helicopter's turboshaft engine thermogas dynamic parameters according to table and step change in the required fuel consumption. The results of a comparative analysis of helicopter's turboshaft engine control task solution on the example of determined fuel consumption using various of neural network architectures are presented in table. The results of determining errors of the first and second kind error according to the main helicopter's turboshaft engine thermogas dynamic parameters are presented in table. The conclusions are presented in this slide. Thank you for attention. Thank you.
Thank you. Thank you. So, dear colleagues, maybe you have some questions. Please ask.
Good day. I'm interested where in Ukraine can the result of your work can be applied?
The results in my work, the high accuracy for identification parameters of helicopter's turboshaft engine. This methods for practically maybe make in expert system for dynamic monitoring turboshaft engine operational status. Developed this authors group in other works.
Thank you for your answer.
Thank you.
Thank you.
Thank you.
And the next report is processing of cerebral cortex neurosignals from AAG, electroencephalographic sensors, and recognition specific types of mechanical movements elements of patient limbs under the cognitive feedback influences. The authors are Mikhailo Petrik, Oleg Pastuch, Mikhailo Baczynski, Ivan Mudrik, and Volodymyr Stefanishin. So, please, now you may present your work.
Hello. Yes, we can. Just a minute. Share screen. Research area. The research idea was to use machine learning for analyzing cognitive feedback effects of SS neurosignal beside of process of encephalograph data of the patient who underwent an experiment. The NeuroCom 16 channel selection of encephalograph computer encephalography complex was chosen studying the brain's encephalography EEG signals. The environment. On this slide, we can see the data reserved for the encephalograph during the experiment for each of the sensors. The patient movement were recorded by the encephalograph at the sampling rate of 500 Hertz, which provided sufficient data. Data flow on this slide, we can see the general schema of the environment. Data processing. After during the experiment, we obtained the significant amount of data that needed to be processed and analyzed. For this, we used the object-oriented program language Python and specialized library pandas, NumPy collections, scikit-learn. Thanks to this, we were able to build the model that can determine which 98% actually which finger was bent at the particular moment in the time. The machine learning processes allowed us to achieve these high actuals and ensure the reliability of the result obtained. To visualize data, we used Matplotlib for some library for machine learning with Python and create the plot that display the value of encephalograph for both LHF and RHF fingers during 2 minutes experiment. Data processing. On this slide, we can see how well our model works. We use standard Scarlet class for the Skylearn library and standardized with MLM. Since after standardization, we split our MLM data set into the two sets in 75 and 25 retail. 75% of the data will be used to train our neural network, and 25 will be used to testing its functions. We use train test split class for the some library for Python. It's scikit-learn library to split data into training and testing sets. Так, machine learning training and testing model. After completing the process of preparing the data and the data of analyzing and process, we process with creation and training of the neural network. This process includes the following stages: model initialization, training, prediction, and environment of the effect files. On this slide, we can see testing data and input data which we set to our neural network machine. As a result, training and testing the MLM, LHF and RHF neural network, we achieved high urgency, which enable us to prepare it for use recognized patient movement under investigation. Example for MLM for recognizing. Right, for MLM recognizing of the patient RHF finger movement feature 1. Illustration for the number of feature matches 1 or null. It's about 5,998 for 1 and 4 for null. Possibly value for features we can see on the picture B. Conclusion. The author provides high performance and huge technology for process dialing EEG signal for the center context CCC to in investigation for state of the human's motor system, because on machine learning using deep neural networks, this approach also for the identification of movement element which consideration of the cognitive feedback loops for the CS neural nodes as future for recognize that specific type of human lips movement high performance algorithms for recognize the movement elements have because development because this approach which enable parallel computing. Okay. Thank you for the attention.
Thank you. Please, maybe dear colleagues have some questions. Please ask.
I would like to ask a question. Thank you very much. The presentation was very interesting. There are a lot of different methods in electrography. One of them you are discussing today. And I would like to ask, how can the results of your research be implemented in medical practice? Because all the time it's very important to apply results of calculations, modulations for practice, and doctors should use such results.
Okay, thank you for these questions. My name is Ivan. I'm a presenter of this topic, of this presentation. So I would like to answer these questions. So we use this in complex of neurology tests for tremor diagnosis, and we use a modeling by machine learning modeling EEG signals compared with the tremor signals from the papers. And we use the comparison between the real EEG signals and modeling EEG signals from paper-written diagnostic tests. So we use machine learning to compare real patient signals with the drawing, with the modeling signals when we use only drawing to compare is this possible to diagnose without using patient tremor diagnosis in the paper. So we use only EEG to understand the signals from brain cognificent with patient tremor limit.
Thank you so much.
Thank you.
Thank you. So the next report is the role of cyber-physical systems and Internet of Things in development smart cities for Industry 4.0. The authors are Martin Bernos, Andrei Mikiteshin, Vitaly Kartashov, Vitaly Levetsky, and Metro Martianov. But they have the technical problems with internet connection, and they can't present this work by themselves. So if you don't mind, I'll use their presentation. I'm sorry. I don't know a reason of it, but I'll connect this video next, if you don't mind. I'll correct it and connect it next. Please, the next report is particularities of the universal SQL programming token for increasing the competitiveness of the enterprises. Authored by Vasil Martsenyuk, Ostap Boyko, and Irina Kramer. So please, are you present here? Ostap Boyko is present. May you present your work?
Good evening, everyone. I'm sorry, I don't have access to my computer right now. I'm on my phone, but I have sent you video to your email.
Okay, so please give me 1 minute.
Sure.
Okay, so if you don't mind, I have your presentation. I'll connect your presentation and then you'll ask on questions, if any, okay?
Yes, sounds perfect. Thank you.
Okay, 2 minutes.
Good morning, ladies and gentlemen. Today, I would like to present for you our scientific research on topic Peculiarities of Universal SQL Programming Toolkit for Increasing the Competitiveness of Enterprises. I and my colleagues, Dr. Vasil Martsenyuk and Dr. Irina Kramer, we examined the issue of using new approaches in improving decision-making at the enterprise through the use of modern technologies for processing large volume of information. It has been found that one of the main factors for increasing the competitiveness of enterprise is the use of an efficient and flexible database that can be used in enterprise for various types. Market situations in the countries of the modern world require enterprises to be very careful about their competitive decisions, and as a rule require the adoption of balanced decisions based on information received from both internal and external sources. With the development of technology, it has become easier for enterprise to collect data, not only from external sources, but also to efficiently store data in their own databases. However, storage is the only first stage of working with a large amount of data. Afterwards, the company needs to structure, process, and analyze this data. For this purpose, businesses invented dozens of programming languages that still help businesses in their daily work. The main actor in the working with large database in large companies is a business analyst. Main task for business analysis is to provide information to decision makers at various levels of the organization. For this, business analysis uses software that stores and structures the information received, a programming language that simplifies work with large volumes of data, and visualization tools that allows you to transform data into familiar graphs and charts. According to the report submitted by Gartner Incorporation in 2021, companies that have promoted quality data storage will have competitive advantage at the market. However, a big problem arises. How exactly to process information that occupies terabytes of memory? This question arises more frequently due to the fact that everyday enterprises store more and more data, making it analyze a complicated task for any driven by data economy. Using SQL, analysis can easily create complex models for analyzing and synthesizing information, minimizing the number of errors and increasing the results quality. It's highly flexible and adaptable and can manage data in various business areas, from large corporations to small businesses. Additionally, there are different degrees of access control, which give the opportunity at the database level to manage the capabilities of users according to their needs and rights. The sphere of use of SQL is vast and diverse. Business analysis cooperates with many departments within the company, helping them to fulfill their direct tasks. For example, marketers, the ability to segment data according to the necessary parameters, or financiers and accountants, the ability to combine many fragmented reports into several standardized formats, engineers, the ability to find glitches and errors in the database, and many, many others. According to a survey in 2021 of Stack Overflow users, MySQL is the most popular database for SQL with 50 approve rate. We also recommend to use it. However, as any technology, it has advantages and disadvantages. We would like to name the following advantages. First, it has a simple syntax, straightforward logic in building queries in databases. A second significant advantage is cloud compatibility. Also, it's free installation. However, there is also disadvantages when working with these databases. First of all, this is the question of scalability. Secondly, MySQL doesn't have a full open code. Another disadvantage is the limited compliance with SQL standards. The structured query language has specific standards, but MySQL doesn't fully adhere to them. Naturally, every enterprise strives to be competitive. As the demand for fast data, the technology increases, and the expectation of combining technical skills with business acumen will become more common. Based on information above, SQL is a unique language used in many industries. However, we believe it's not the only one. Living in an era of information, we believe it's only the start point of our journey, and the importance of proper storing and analysis of big data will only increase in daily manner from year to year. As Andrew McCarthy once said, the world is one big data problem. That's why the main task of our research is to make the world simpler and more.
Thank you.
Thank you for your
Dear
attention.
colleagues, maybe questions? Any questions, please? Okay, no questions. So let's continue. Thank you. And the next report is optimization methods for determining coefficients of mathematical model of electroretinographic signal for detection of neurotoxicity risks. Authored by Pavlo Tymkiv, Alexandra Klos-Witkowska, and Igor Andrushchak. So please.
Good day. Dear Chairman and the workshop participants, I am presenting the research result of the topic optimization method for determining the coefficient of mathematical model of electroretinal signal, which with each passing year, increasing number of new chemical compounds are being used in production and daily life, and evidence is statistical data. More of these compounds are influences studied. While statistics on their usage are available worldwide, USA, Canada, Europe, there are lack of data in Ukraine. There are standard electroretinographic methods for diagnostic tools for early detection of toxicity. The experimental scheme for low-intensity electroretinal signal sampling in present to Figure 1. Expert system exists for assessing such effects. The function of such a system is based on the user mathematical model with corresponding parameters, coefficient of mathematical model, and coefficient adjustment method. Known, the method of parameter identification is based on direct search of all values of two coefficients, A1 and A2. To determine the parameters of the mathematical model, coefficient of different equation, a method of direct search of brute force was used, which granted predictable accuracy, convergence, but the computational intensity. Another known method for determining the model coefficient based on the Hooke-Jeeves algorithm. However, it also has several drawbacks, such as dependency of the initial start point, high number of iteration, and sensitive to noise. The gradient method is efficient algorithm for minimization quadratic function in nonlinear space. The main idea of this gradient method is that each subsequent destined direction is choose to be all preview direction, allowing for faster convergence for function minimum. To compare the efficiency of method, a study was conducted on a tested electroretinal signal with different number of sampling points and the time for coefficient determination in MATLAB. The table shows that the gradient method has significantly lower time compared to the brutal force method and less time compared to the Hooke-Jeffs algorithm by approximately 10–15%. The graphic depends of the coefficient determination time on the number of sampling points used. Different methods shown in figure 6. And the obtained results are follows. The results indicate that the gradient method are most suitable for optimization coefficient of mathematical model of electroretinal signal for detection of the narrow CT risk, as they offer faster convergence and lower computation time compared to the brutal force and Hooke-Jeffs algorithm. Thank you for your attention.
I'm sorry. Thank you. Thank you for your report. Please, maybe dear colleagues has some questions. Please ask. No questions. Okay, so thank you. And the previous presentation is not supported by Zoom. I'm sorry. I'll try to change or reconvert it and present it later. And now, according to the program, I suggest to make a break, coffee break, a little coffee break. And let's continue after the break. Okay? So thank you for your presentations. Thank you all participants of this part of our workshop. And let's continue after coffee break. Good day again. Please tell me, can you hear me? Okay, so let's continue. And the next, our report is specialized information system of support in the process of recruiting securities. Authored by Taras Dubinyak, Alexandra Manzi, Tomasz Garkanjuk, Andrei Sanik, and Yuri Futrik. So please.
Hello, my name is Yuri Futrik, and I'm very happy to represent you our topic, specialized information system of support in the process of recurring securities. Due to the significant increase in investment and investment activities, not only by specialized organization and professional investors, but also by private individuals, there is a need for accessible instrument for monitoring the financial securities market. Investment risk is a threat of full or partial failure to achieve the planned investment objectives. As a result, monetary losses are incurred. All investments carry a certain level of risk. So risk management is defined as a process of identifying the risk associated with a particular investment and then making that risk in the best possible way. Nowadays, there is a growing number of software that helps investors to carry out assets transactions in every possible way. This slide represents the hidden levers and Sigma platforms. Both solutions provide secure asset management of portfolio activities. Also, they are cloud-based platforms and included model building, investment proposal generation, and investment risk monitoring. The programming language chosen for this application was Python. Thanks for its powerful libraries, this programming language provides a significant advantage in the development of software when working with especially investment risks. This language also has the following software solutions like Jupyter Notebook and Web Framework Dash from Plotly. The next slide describes the main libraries that were used during research and development. NumPy for scientific computing and for working with data sets, Pandas to analyze information and work with data frame, SciPy for handling big data and for technical computing, and Matplotlib to create graphs, histograms, charts, and more visualization. This slide presents possible sources that provide open APIs for updating historical and current stock market values. This type of data is available from many sources, such as Yahoo Finance, Google Finance, Quandl, etc. In part of research, it was compared the above APIs and concluded that Yahoo Finance is the best option to use in conjunction with Python libraries. The paper analyzes stock market data, namely the stock of large technology companies such as Apple, Google, Microsoft, Amazon, Tesla, and Boeing. The stocks were researched and compared, and graphs were built to help find differences, as well as to analyze financial changes in the market and understand how events affect the stock price. The main emphasis was placed on the adjusted closing price of stocks. The charts visualize the closing price for selected companies and a moving average. The average value is taken over a time period of 10, 20, and 50 days. In the research process was used ARIMA forecasting model to predict whether the stock price would rise or fall. The forecast is shown on the left, and below is accuracy relative to actual performance. On the right is a chart of the closing price for the stock price and the added cryptocurrencies such as Bitcoin and Ethereum. The next step is to select the most efficient investment portfolio. So Python provides a fast Monte Carlo simulation to build 10,000 random portfolios. The program selects the best portfolio to invest in, taking into account the risk-return ratio of the entire portfolio. This table shows the final risk assessment for the selected portfolio. Also, risk is measured by the standard deviation, Sharpe ratio, and also the rate of return. All charts are dynamic, which was achieved using the Dash web framework by Plotly company. As application will help analyze and forecast certain types of tech stocks in real time. It should be noted that this product is focused on the non-professional investor. The paper provides an overview of specialized application software products that are available in the open source, working in the field of risk and investments. Also using the Python programming language with its libraries for analysis, the Python notebook, web framework Dash from Plotly application. This application was created that based on a risk analysis method, processed the available data and provides appropriate visualization of the possible risk for the selected assets. Applying the newly created product, the risk of the investment products included in the process of recurring securities were analyzed, and the most preferable securities were selected according to the forecast, taking into account possible income and the potential financial risks. Based on the results of the analysis and the research, a specialized information system of support in the process of recurring securities was created, and it published as the following address. So thank you very much for your attention, and if you have some questions, you can reach out to me.
Thank you. Dear colleagues, maybe you have some questions, please ask reporter. No questions. So thank you. And the next report is linear random process model-based AAG classification using machine learning techniques. Authored by Mikhailo Freys, Leonid Shcherbak, Bogdan Ablenko, and Taras Mikhailovich. So please.
Good afternoon, dear colleagues. My name is Mikhailo Freys, and I'd like to represent the results of our research titled as Linear Random Process Model-Based EEG Classification using Machine Learning Techniques. The electroencephalography signals are recordings that capture the electrical potentials of the brain's activity. These measurements are generally non-invasive, using electrodes placed on the scalp. EEG data can give us important information about various brain disorders that affect a wide area of the brain. Another great area of EEG analysis is related to the creation of complex information systems based on the brain-computer interface concept. Usually, EEG analysis for both medical applications and BCI applications includes mathematical modeling, feature extraction, and classification methods. Linear models and techniques are significant in the field of EEG signal processing. The continuous time linear random process, which is represented on this slide, is the biophysically reasonable mathematical model of EEG, representing the signal as the sum of many stochastically independent excitatory and inhibitory postsynaptic potentials, which are generated by the neurons in the cerebral cortex in response to the spike train considered as the Poisson arrival process. The autoregressive model is one of the most important particular cases of discrete time linear random process. So the objective of our paper is to justify the informative features of EEG signals based on the kernel of its representation as a linear random process, that is
the kernel is phi of tau, and to investigate the machine learning classification techniques based on the extracted features. The feature extraction methodology has been represented on the slide. It includes the EEG signal acquisition and pre-processing, order estimation of autoregressive model, covariance function estimation, solving the Yule-Walker equation for finding the autoregressive coefficients, which is based on the above covariance function estimation, and finally the estimating the samples of the kernel of linear random process representation of EEG signal. Several binary classification techniques have been compared using the data set consisting of electroencephalograms of about 23 seconds with the sampling rate of 173 and 61 hertz. Generally, the realizations have passed the wide sense stationary test, and the eye movement and muscle activity artifacts have been removed. The binary classification tests, which will be presented later, have been analyzed based on the healthy persons with open eyes, which is class A, and closed eyes, the class B. The covariance function estimations of the above signals have been represented on this slide for the class A and for the class B signals, and that estimations have been used for the parameters estimations. The kernel of EEG representation in the form of discrete time linear random process has been estimated then as the impulse response of corresponding recursive filter related to the autoregressive model, which is estimated above. So you can see the two representatives of the estimated kernel for the class A and class B. Finally, the performance of several classifiers have been represented on the slide. Comparing the results, we can conclude that extra trees classifier based on the second feature set. Yeah, so the second feature set is the feature set consisting of the samples of the kernel, so that outperforms the other considered algorithms based on the fast feature sets. The conclusions have been represented on the slide. Thank you for your attention.
Thank you. Dear colleagues, maybe someone has questions about the report, so please ask. No questions. So thank you very much. Thank you for your report. And the next report is a development of model predictive control algorithm for managing the deformation of a multi-layered soil massive under mass and head transfer. Authored by Natalia Zhukowska, Viktor Moshinsky, Viktor Lukovsky, and Andriy Srstyuk and Oleg Pinchuk. So please.
Hello, everybody. Can you see my screen?
Yes, we can.
Okay, thank you. So, dear colleagues and participants of the conference, my name is Viktor Zhukovsky, and I would like to present our scientific research regarding development of model predictive control algorithm for managing the formation of multi-layered soil massive under heat and mass transfer. As all we know, soil is a heterogeneous environment that naturally consists of multiple layers, such as sand, clay, loam, humus, and chernozem. Previous studies have investigated the process of filtration, mass and heat transfer, and stress-strain state in soils in the presence of pure water. However, in natural conditions, various saline solutions are also filtered, and the effect of temperature is present. Filtration is slower in clay soil layers and faster in sand, indicating that these factors can affect the stress-strain state of each layer of the soil massive. These processes can also affect the stability of facilities built on such soils and result in unpredictable accidents and significant economic losses. That is why computer and mathematical models can be used to study these processes, with three-dimensional modeling allowing to build an adequate description of physical processes. So let us make the formulation of a physical problem. We are considering the multilayered soil massive with a free surface in the three-dimensional case. As we can see on the figure 1, there is a special scheme of a multilayered soil massive with a free surface. There are a number of layers in the soil massive, and the layers are numbered from bottom to top. And we gave the name like omega for the first for that area. So based on this formulation of the problem, we build the mathematical model. It consists from system of equilibrium equation in the form of Lamé for soil massive displacement, and obtained on the generations and obtained on the basic Hooke's law, taking into account heat and mass transfer and dependencies of Lamé and Young modulus, coefficients on salt solutions, concentration, and temperature. So besides that, we also have the components of the mass forces in all layers of the area calculated by equation number 2. And also Cauchy relations are expressed by dependencies of normal and tangential strains components on displacements components by equation number 3. There are also normal and tangential stresses based on the generalized Hooke's law in inverse form, and the law of parity of tangential stresses taking into account the dependencies of Lamé coefficients. We may see all that equations on the formula number 4. Also, in our university, scientists performed a series of physical experiments, which allows us to find the dependencies of the Young's deformation modulus, nonlinear dependencies for the salt solutions, and that dependencies from the concentration and the temperature. So there are the Young deformation modulus and Lamé coefficients for the salt solutions. Like one dependency is nonlinear, we find out the necessary coefficients. Second dependency is with necessary coefficients. Third, and also the fourth one. So it was non-trivial task, because to find such dependence from two parameters is not so easy. And for example, we may see how it looks like. The real data experiments are red dots, and the other find dependencies is presented as such surface on the figure number 2. This is the dependence of the filtration coefficient on the concentration of the filter solution and temperature. We made a program realization for performing numerical experiments, and we took into account the rectangular parallelepiped of length 10 meters, thickness 10 meters, and height 10 meters. The free surface is located at the level 7 meters, and under the area of clay soil has a height 3 meters. with the following initial data presented on the slide. After the series of numerical experiments, we find out a lot of new scientific research, and due to the lack of time, we are presented few of them, like distributions of displacements in different planes, like on the figure 3, distribution of displacement in cross-section by plane YOZ at the length, at the depth 5 meters, distribution of displacement in cross-section by plane XOZ at the depth 5 meters, and distribution of displacement in the cross-section by plane XOY at the Z depth 5 meters. So let us make brief conclusions. In this scientific research, we formulated the physical problem. Also, we built the mathematical model for the spatial deformation processes in the multilayered filtering soil massive. As a result of numerical solution and computer modeling of the corresponding boundary value problem, we find out displacements, normal tangential deformations, and stresses, and that allows us to make the estimation for their influence on different regions, subregions of the soil massive. We see that the largest values of spatial displacements are achieved in the subregions of water-saturated sandy soil. And it is obvious because in the sub-area of clay soil, the displacements are smaller due to the slow passage of pollution, filtration, and mass heat transfer. That's all for our presentation. Thank you all, and we are open for your constructive questions and discussions. Thank you.
Thank you, dear colleagues. Maybe you'll have some questions. No questions. So thank you very much. Thank you for your report. And let's continue. The next report is decision-making automation for UAS operations using operative meteorological information, authored by Yulia Avryanova and Eugenia Znakovska. Are the speakers present here?
Yes, one moment. Thank you for your presentation.
Thank you for your present here. So
marks. The automation of many processes during the productive activity and service provision, integration of different technologies, and implementation of Internet of Things in different branches of industry, active utilization of cloud technologies, and looking toward the artificial intelligence and machine learning in the operation of industrial facilities, identify this current period of industry transformation as Industry 4.0. In turn, the progress in engineering and technologies in various areas of industry has become a driver to use the range of sensors and special software to obtain, process, and analyze the huge volumes of data. On one side, The increased volume of information helped to increase the efficiency of different operations, optimize them, implement predictive maintenance, help when decision-making. On the other side, the information should be properly processed and analyzed. It should be relevant and contextualized as well. This, in turn, required the development of the methods and algorithms to operate with this data for further use in decision support systems or in the systems of automated control of industrial operations. One of the technologies that can be successfully used to obtain real-time data at different stages of productive activity is unmanned aircraft systems. Some advantages of using UAS for different industrial applications indicated at the left panel of the slide. At the same time, there can be distinguished some restrictions on drone operations. They are connected with the hazards and risks when UAS operations. The risk analysis should consider the nature of modern UAS system as cyber and physical systems. The risks can be divided into natural and man-made and intentional and unintentional. An example of intentional man-made risks can be the cyber risk. The natural, unintentional risks are often connected with meteorological hazards. This is because the operation of the physical and cyber parts of the UAS is dependent on the weather. Information about the meteorological situation and weather phenomena that can impact the UAS flight and operation is highly important for different industrial applications. So it was our motivation to organize the vast, diverse, general and operative information and to enhance the automation of the process. In this paper, we have made the analysis of weather-related risks for UAS focusing on agricultural application. The peculiarities of such analysis is the weather-related restrictions not only for UAS flights, but also for different agricultural mission performance restrictions and restrictions for the devices and sensors that can be used for mission realization. The summary of the analysis is shown in the table on the slide. After analysis, we define the factors that should be taken into account when decision-making and consider them in the developed algorithm. The list of the factors are shown in this slide. The first 4 factors are introduced in the algorithm as input data, then the meteorological general information. At this stage, the meteorological data can be collected from the available resources, including specialized and general internet resources and official meteorological databases. Then the calculation of UAS characteristics for current weather conditions is made. The next step is the comparison of UAS sensors, mission and area weather limitations with present meteorological conditions is made. After comparison and evaluation of the possible weather-related risks on the base of a risk-oriented approach, the recommendations to perform the flight and fulfill the planned mission are issued. But the atmosphere is a highly dynamic medium. So the key thing of the algorithm is that after the beginning of the flight, the UAS is used as the mobile platform to obtain real-time meteorological data. This data from one side is transferred to the cloud service from which it can be used by other participants of flight on demand and to form the data set of real-time data for operative use. And from another side, it is used for operative correction of initial meteorological data and to forecast the boundary layer turbulence. So the algorithm makes the comparison of the operative data with initial meteorological information. If significant deviations or turbulence presence, then go to the re-evaluation of the limitations. In this case, the new recommendations can be given. On the basis of the proposed algorithm and weather-related hazards analysis, we developed the software for the automation of UAS operators' decision-making. In this slide, it is possible to see the interface of the application and 3 simulated decision-making cases. We can see for the first 2 cases, the state of the atmosphere for general flights and planned mission is quite favorable. The third mission, spraying chemicals, can be performed when wind speed is above 4 meters per second and the absence of any convective movements. So the average wind 5 meters per second is below the required minimum for the given mission. And to conclude the presentation, it should be mentioned that the developed decision-making software allows to provide the individual user-oriented services, obtaining but are not restricted. Information on demand, real-time information, information for interested area, mission-oriented information. The use of UAS as a platform for sensors placement to obtain operative data allows to form the database that can be located in a cloud service for the convenient use of the interested authorized user. The information can be continuously exchanged between humans and machines and between machines and machines as well. Thank you for your attention.
Thank you, dear colleagues. Maybe you'll have some questions to reporter. No questions. So thank you again. And let's continue. The next report is analysis of approaches to identity verification during knowledge assessment in learning systems, authored by Oleg Shkodzinsky, Alexandra Klosvitowska, Mikhailo Lutsky, and Denis Sas. Alexandra Klosvitowska is present here. Please, maybe you'll start this report.
Hello, I'm here. It's very nice.
We are glad to
very
see
nice
you here.
to be here. Yes. Do you hear me?
Yes, you can.
Yes. Okay. So first of all, I would like to thank you very much for possibility of being here. My name is Alexandra Kłos-Witkowska, and I represent the University of Bielsko-Biała in Poland. Before I give the voice to my colleague from Ukraine to present the paper, I would like to tell you a few words about the project which we are working on right now. The project name is Future is in Applied Artificial Intelligence, and the project is co-founded by European Union, Erasmus++. The aim of the project is create the courses for students, teachers, and also for alumni if they want. It is of course connected in artificial intelligence, and it is based of market requirements. Now we are still working on preparing the model. The model contain lectures, case study materials for students, and when the project will be ready, we are going to put in on this platform for normal using. I would like to also mention that the project is involved five universities. That means in the project take part University from Bielsko-Biała, which I represent here in Poland, but also our colleagues from Serbia, Bulgaria, Montenegro, and Slovakia. Hope that we will finish soon and everybody could use this materials for education. So thank you very much for for your attention. And now I'd like to give the voice to my colleagues from Ukraine to present this paper. So thank you once again.
Thank you very much. Thank you. We'll continue. 2 minutes, please.
Hi everyone, I'm glad to introduce you results of research on the topic Analysis of Approaches to Identity Verification During Knowledge Assessment in E-Learning Systems. Distance learning forms of education have been around for quite some time, but the real surge in their popularity was due to the quarantine restrictions during the COVID-19 pandemic. Distance learning has its own challenges. While the problem with individual assignments was solved more or less quickly, the remote assessment of knowledge by means of testing still raises many questions, starting with the security of personal data and ending with a significant number of opportunities to violate the knowledge assessment procedure. Modern proctoring systems leverage hardware and software technologies to tackle this problem. They are widely used now in distance education. One of the technical components of proctoring system designed to solve the test cheating problem are specialized means of identity verification. In this research, we've tried to analyze approaches to solving this problem made by different proctoring systems. The goal of this study was to analyze the most widely used technical solutions for identity verification in e-learning systems, to classify the main approaches to choose optimal option for use in e-learning system based on LMS eTutor. We have compared the most successful proctoring solutions and analyzed their approaches to the problem of identity verification. All solutions use web camera or phone camera to capture photos or video stream of the person who takes test. Solutions like Exam Online, OES, ProctorTrack have automated face recognition feature using AI technology. Other solutions use human proctor to verify identity of the person who takes test. Moodle proctoring has also automated face recognition, but only using paid third-party services. ProctorTrack has feature of automated ID card, student card recognition using AI. Interesting features of other systems include support of 360-degree camera, very effective approach but requires a special hardware 360 camera. Other interesting feature is knuckle scans, identity verification using relative length of fingers of a hand. Based on the results of analysis, the following conclusions can be drawn. Solutions like OES, Moodle proctoring, ProctorTrack, Proctor.io allow to fully integrate them into common e-learning systems, to use existing database of test questions and already configured tools for knowledge assessment. The rest do not. All solutions except Moodle proctoring are commercial and closed source, and therefore do not allow any modification, customization, and improvement. Considered technical solutions do not have the ability of direct integration with LMS eTutor in any way. And none of the solutions provide a guaranteed high percentage, 95% or more error-free result. All these reasons determine the need for further research with the aim of developing and implementing a technical solution using AI technologies which would ensure automatic and effective verification of identity during knowledge assessment, leveraging web technologies and common software and hardware of users that they use on a daily basis. The desired solution should have at least 95% accuracy and perform 1 second per identification or better to be able to work in real time. It also should be able to integrate with LMS eTutor to use its test question database, and built-in knowledge assessment tools. Further research is continued. That's all for this. Thank you for your attention.
Thank you. And the next report is gas consumption forecasting using machine learning methods and taking into account climatic indicators. Authored by Grigory Shemchuk, Yaroslav Litvinenko, Roman Gotovich, Sergei Litvinenko, and Volodymyr Gotovich.
Can you hear me?
So please, good day.
Hello, I have to share my screen, yes, to show you my presentation.
Yes, it is.
Yes, as I can see, here is my screen. So, okay, I'm ready. My name is Volodymyr Gotovich. I work as an associate professor of computer science department in Ternopil Ivan Poliy National Technical University. And let me present main results of the research on the topic gas consumption forecasting using machine learning methods and taking into account climatic indicators. Briefly about the relevance of our research. The growing demand for energy consumption in various industries creates the prerequisites for the development of many methods and models of optimization and control over the use of the natural resources, and of course natural gas consumption is no exception. The subject of processing and forecasting natural gas consumption attracts significant interest, and new mathematical models in gas consumption processing and especially forecasting methods using machine learning techniques are of particular interest. As you can see, many researchers are engaged in the development of gas consumption forecasting methods. In our paper, we examine a method for gas consumption forecasting based on the application of an additive mathematical model. And our forecast is constructed using machine learning methods, specifically gradient boosting and decision trees. Main results of our research. We use the model of the cyclic random process of gas consumption, expression number 1. This is an additive model which consists of 3 components: cyclic component, trend component, and stochastic function reminder. In practice, when we have to deal with discrete data, we use the form of our model, expression number 2. Pay your attention, here we consider a cyclic component of our model, C with index omega. And this component carries information about the gas consumption process. And we present this component in the form of equation number 3. In our model 3, there are segment cycles of gas consumption, and they are determined through indicator functions. Expressions number 4, 5, and 6. We use the segmental cyclic structure, capital D with index C, which takes into account by a set of time counts. This form of our model 6 takes into account the rhythm of the cyclic process through a continuous function of the rhythm, expression number 7. Of course, it's necessary to take into account changes in the amplitude of the load along segment cycles. These changes are caused by various climatic factors, for example, air temperature, pressure, wind force, and others. And we use a special vector here with index n. In our model 4, we take into account multiplicative component by using indicator functions and scale coefficients. Expressions number 8, 9, and 10. For our climatic indicator vector here with index n, a fair ratio that takes into account the climatic parameters that affect gas consumption in each segment cycle for the cyclic process, namely expression number 11. Now, let's move on to the results of practical implementation. Figure number 1. Here you can see a fragment of input implementation of cyclic gas consumption process during several years. Figure number 2. Here you can see important components of our process, especially trend component, figure 2a and figure 2b, stochastic residue. And on the figure number 3, you can see a graphical presentation of the cyclic component. This is an important component because we use it for forecasting purposes. On the figure number 4, you can see a graphical presentation of the maximum values of climatic indicators that affect the gas consumption process, especially air temperature, atmospheric pressure, relative humidity, and the maximum values of the wind gust. And figure number 5, there are two approaches to forecast gas consumption values using different input data for training. We use incoming data in the form of the gas consumption process in general, 5a figure, and figure 5b, incoming data for training our neural network in the form of the cyclic component, only the cyclic component for gas consumption. We apply two models and two sets of data to forecast gas consumption. For the first approach, we take a neural network model of gradient boosting and a model based on decision trees for neural network training. Here we use input data in the form of the gas consumption process. The results of gas consumption you can see on the figure number 6. On the figure number 7, you can see the results of gas consumption of the second approach. Here we use the neural network, a model based on gradient boosting, and the model based on decision trees for neural network training. But here, as an input data, we have used only the cyclic component of our gas consumption process. Briefly, analysis of our results. It follows that the root mean square error for the case of applying the gradient boosting model is larger than in the case of applying the model based on decision trees. And conclusion of our study, you can see in the last slide, number 15. It was found that their forecasting method based on the model of decision-making trees more accurately informs the forecast of gas consumption values. And we found that the forecast based on the learning of the input data in the form of a cyclic component of gas load, only of cyclic component, gives better results compared to the forecast based on the input data of gas consumption. Thank you very much for your attention.
Thank you. Please, maybe participants have some questions. Dear colleagues. No questions. So thank you. Thank you very much for your report. And let me present the last report. The authors of this report has technical problems, but one of authors is present here. So I'll connect the video presentation. So please give me 2 minutes.
Good day, dear colleagues. Today I would like to share with you the results of my research on the topic, the role of cyber-physical system and Internet of Things in development of smart cities for Industry 4.0. Nowadays, when technologies are developing so quick, and our cities and also claim the status for smart cities, the combination of cyber-physical system and the Internet of Things plays the important role in realizing this goal. So let me start from the definition. Cyber-physical systems are a set of the infrastructure and production system that combine the cyber technologies integrated into the physical environment with the human interaction. CPS described the next generation of complex engineering system that incorporate the cybernetic aspects embedded in the physical world. They apply computing, communication management, information technology, and physical processes. The cyber-physical system of a smart city, which includes the following layers, as well as the role of the Internet of Things, can be implemented as follows. Cyber layer covers the informational and communication technologies. They are responsible for collecting, processing, and analyzing the data. This layer includes the Internet of Things, sensor networks, surveillance cameras, data collection, and machine learning system, and others. Physical layer includes physical components like buildings, roads, vehicles, critical infrastructure, the power supply or water supply. This layer includes sensors that collect data on physical parameters such as temperature, humidity, the air quality, and etc. The third layer is a real layer that covers the real processes and events in the city. For example, the movement of people, the traffic, provision of certain services, and so on. The next step after data collection is analysis to optimize city operation and improve services. The personal layer includes the information about smart city users, such as their health level and service needs. The collected data can be used to provide the individualized service that can be improve of quality of life. The last layer is the environmental layer. This is the environment in which the smart city develops. This layer includes factors such as weather condition, pollution, the climate change, such things. One of the relevant data, once the relevant data is collected, it can be used to improve the environmental sustainability and zero impact on the environment. In general, the concept of the smart city was developed by combining the several areas, such as smart construction, the emergency response, the smart transport, and the smart networks. Smart city are large-scale CPSs that continuously monitor events in the real and the virtual life worlds. This, in turn, affects the executive mechanisms that changing the urban environment. The Internet of Things in network of physical devices equipment, vehicles, and other objects that have built-in sensors and software are able to exchange data with each other and in the accounts in the internet. This makes it possible to collect and analyze large amount of data to provide the efficiency and quality of life in cities. By combining the concept of Internet of Things and cyber-physical system, we can understand how they affect of development of smart cities for Industry 4.0. One of the main aspects is the improvement of cities infrastructure. As thanks to the CPS and IoT, we can implement smart management system for energy, for water supply, for waste, for lighting, and etc. For example, cities can install sensors and collect data on air pollution level, traffic, noise level, and so on. This data can be analyzed to make decisions about the traffic optimization, the air quality improvement, and other aspects of city life. Security and emergency response is one of the main issues in the smart city environment. The city-wide video surveillance network, which combines the resources of public and the private organization, can be combined with automation to detect and monitor threats and incidents in real life and in real time. In addition, CPS and IoT are influencing Industry 4.0. Production systems are becoming more automated and smart. They provide data collection from various sensors, which allows to analyze and predict of equipment operation, plan and optimize the processes. That helps to reduce cost, increase productivity, and product quality. The application of CPS and IoT also extends to smart homes and smart infrastructure. We can have the IoT connected devices in the homes that control heating, lighting, security, and other aspects. However, with all the benefits of the CPI and IoT, there are challenges we faced. One of them is the issue of privacy and data protection. The collection and processing the large amount of data requires a high level of cybersecurity and privacy protection. Researchers are working on the CPS intrusion detecting technologies to prevent such incidents. Different types of IDS devices capable of behavior-based detection, knowledge-based detection, and also host-based testing and network-based testing are currently is being studied. In conclusion, I want to emphasize that cyber-physical system and the Internet of Things plays an important role in the development of smart cities for Industry 4.0. They provide the opportunities to improve efficiency, productivity, and quality of life in cities. However, we must carefully address the challenges of data privacy and standardization to ensure the security and interoperability of different.
Dear colleagues, all the reports scheduled for today have been presented. On behalf of all the workshop organizers, I want to thank you for the great work done, and especially for our Poland partners for their work and their help. And this concludes the work of the first day of the workshop. The workshop will continue tomorrow according to the workshop program. So thank you. If you have some questions, please ask, and have a good day and stay safe. Thank you.
Thank you very much. Have a nice day.
Thank you.
Okay, thank you. See you next day. Goodbye.
Thank you. Goodbye.
Thank you.
Thank you very much. Goodbye.